welcome to the Innovation Blueprint podcast. I'm your host today here, Paula Szyszkowski, and we have Peter Stark from Cybuzz 21. Peter, thank you so much for coming on the show with us.
Well, my pleasure. Thank you for having me, Paula.
Tell us about your background and what led you to start Cybuzz 21.
Well, I was actually not one of the originators of it. However, I came in about a year into its incorporation. Cybuzz 21 is probably the culmination of a career that started as a computer nerd 30 plus years ago. My career sort of paralleled the evolution of the desktop computing revolution, so that I was always on the business system side of things. I have an undergraduate degree in political economy and a master's in marketing and operations research. I've worked for Fortune 500 companies, consulting companies, and then took a little bit of a deviation in the wine industry, trying to rescue a bankrupt wine company. And then from some of the principals in the bankrupt wine company, we worked on the Cybuzz 21 concept, which is getting a better value of energy out of existing technology.
Yeah, and tell us a little bit more about what Cybuzz 21 does.
Well, our principal product is a device that allows diesel engines to burn more efficiently and pollute less. So that, particularly now that diesel prices are going way up because of the current international situation, what we do is get about 20 to 25% more efficiency from any diesel engine, whether that's in a truck, a generator, in maritime situations, in construction equipment. Basically, what we do is we take a little bit of propane gas and introduce it into the air intake, and the propane allows the diesel droplets to burn more completely. When you get more energy per unit of diesel fuel, you are getting less pollution. So we cut back on CO2, we cut back on carbon monoxide, and we certainly cut back on NOx, which is nitrous oxide and its other related compounds. Basically, NOx is much more environmentally unfriendly than even CO2 or carbon monoxide.
Okay, yeah, very interesting. And so you mentioned that you work a lot with the trucking industry. And so you install, I'm assuming, a hardware product and the engine. Tell us a little bit more about what that product looks like and feels like.
Well, correct. I mean, since we're only putting in less than 5% of the air that goes in is actually propane, we throttle it using a proprietary technology. We read information from the engine. We do not touch the engine itself, but we have an interface that interrogates the engine's onboard computer. We read 20 or 30 different variables as far as how the engine is performing. And based upon that performance, we will put in anywhere between 0% and 5% propane into the intake manifold, whether it's an external turbocharger or whether it's just standard air intake. It works on large engines, it works on small engines.
Okay, interesting. And so how are you collecting this real-time data, as you mentioned, to know exactly what to put in the propane?
Okay, well, we have a partnership with Diesel Laptops in South Carolina. Diesel Laptops creates not only training programs for the trucking industry. So, for example, repair technicians would go through Diesel Laptops training. They also have a series of hardware, including an interface that plugs in to the 9-pin computer port that's on every truck since about 2007. So that we basically pull the data from that computer interface using Diesel Laptop software. It parses down the data, refreshes the data several hundred times per second, and lets us even know, for example, if there was a light bulb burned out in a turn signal. It's that granular. So we look at the operating temperature, we look at the composition of the exhaust going out, and based upon that, we know whether there's throttle more or less propane into the intake manifold.
How do you process that intake of propane? Is that done like manually every single time, or is it through the machine that kind of connects?
No, the we have what's called a Greenboxx. It's a, trademark pending. It's literally the portmanteau is Greenboxx, Greenbox, and that basically allows the information from the decoder that is plugged into the computer. There's a proprietary algorithm that we use, and based upon the engine performance data, we control valves that will allow between 0 and 5% gas to go in. And we just use a basic propane tank that you would have for your backyard barbecue, for example. So it's a 25-pound tank. On larger trucks, longer distance, we have two of them, so we can switch over from primary to backup. But the key thing is that propane needed to have a distribution network almost as diverse as diesel fuel is here in the United States. And it turns out that many, many truck stops, because of recreational vehicles, have swap out services for the propane. So you take an empty tank of propane. After you fill up your diesel fuel at the pumps, you go to the swap out station and you exchange the empty for a full one, pay for it, and then just attach it back onto our device.
Okay, very interesting. So actually, it's not a huge hassle to find propane for the truck drivers or for any users of CBUS 21.
At least here in the United States, it is not that difficult. And obviously, depending on whether you have got a transcontinental truck fleet or whether you are doing local deliveries, many, many places have propane as part of their distribution chain anyway,
Hmm.
so that you could uh, basically have a refill on your own depot. The other thing is 2/3 of all Walmarts in North America have propane exchange for this size tank. So if you're not near an interstate highway with a truck stop, you're probably within 20 or 25 miles of a Walmart.
Right.
And on most of those Walmarts, you can make the exchange.
Take us kind of through the user experience, and we'll focus right now maybe on the truck drivers specifically. But from them, like the second they decide to use CBUS, what does that look like for them?
Well, basically, we would have a team of two engineers come out and actually do the installation, because each truck is a little bit different in the sense as where is their real estate, meaning a space to lay the device down. We take voltage just from the battery of the truck. We need to have some place to put the two tanks of propane, at least initially, and usually it's behind the cab. But in some cases, if the trailer of the truck does not allow space for that, we can attach it to the side of the vehicle or slightly underneath. That's what the engineers are there for, so that you not only have a safety
Mhm.
installation, but you also have something that's efficient and that can give the truck driver information back on how he or she are working in conjunction. And they will see it in terms of getting better mileage.
Okay.
So it's a impactful. There's an economic impact that usually pays for itself. If you're doing 100,000 miles a year, it pays for itself in less than a year.
Okay, those are very interesting numbers. And then I'm assuming propane, I actually have never bought propane myself, but I'm assuming its cost is not as high as obviously diesel or
No, the payback period is including the cost of the propane. It's including the cost of the device itself, and it's
Mhm.
including an annual maintenance contract. Basically, we've made everything modular so that if there is ever a need for servicing, you don't actually tinker with what's on the truck. You simply replace one of the components in the field. We have a program with Love Truck Stops and hopefully with Flying J coming up that will actually allow their maintenance facilities on in those truck stops to service our components as well. So when a truck driver goes in, needs tire changed, needs oil changed, whatever, they can also have their device checked out.
Okay, yeah, that makes sense. And I was actually going to ask that this question next is where can Cybus technicians be found? Is it all over the state, like the United States, or are there specific states that you operate in mainly?
Well, we were concentrating our first rollout in the Northeast. And what I mean by the Northeast is I'm here in Hoboken, New Jersey. So I am literally right across the Hudson River from lower Manhattan. We are looking for the New York, New Jersey, Connecticut, and Pennsylvania markets right now,
Hmm.
although one of our engagements is with a major soft drink company, bottling company, and they are actually all the way up and down the East Coast. So I would say from Maine down to the Carolinas,
Hmm.
we would have it. And in cases where we don't have the install technicians there on call, we would either send them out or we would train their depot people how to install on their own.
Okay, okay, great. And this wouldn't be the innovation blueprint podcast if I didn't ask you. So obviously, there's a lot of hardware pieces and installations that go into Cybus 21, but there's also a lot of software like that diesel software that you're using for data recognition, real time performance data. And so I'd love to hear from you. What do you think? Where is the real competitive edge right now? Is it in the data collection, or is it really in that physical technology?
No, our secret sauce is really based upon the algorithm that we delivered in over a decade worth of testing. There were predecessor systems in Europe that we benefited from. And the idea of introducing a volatile hydrocarbon into the combustion chamber was not new. What we see as new is the fact that we know how to throttle it properly based upon real time conditions. At the same time, we're also safety conscious so that when the engine is turned off, we can immediately cut the gas flow off so that there's no danger from that. And as a matter of fact, our system works so well that when you run out of propane, you can still run the truck just based upon regular diesel fuel. There's no uh, shutdown or cut off based upon that. So until you get to a place where you can buy new propane, the truck driver is not stranded on the side of the road. They just continue as
Mm,
if they were not using our system.
right. That makes sense. So there's definitely like that catch safe process that they can take into account. And just take a step back here. You mentioned throttle. Can you explain what that means to a lot of the listeners that probably don't know?
Well, basically, let's say when you're making your barbecue in the back, you basically turn on your propane, and there is usually some sort of a dial on your grill that will make the flame go up and down. And you can either slow roast something or you can sear something
Hmm.
based upon the intensity of that flame. We're doing the same thing, except with a flame we are simply introducing it into the combustion chamber of the diesel engine. And based upon whether you're going up a hill, down a hill, whether you have a big load, whether you have no load at all, that determines how much energy you need at any one given time. And that's linked to both the fuel injector controlled by the truck driver pushing down on the accelerator or not,
Hmm.
and then it's also based upon if you're coasting down a hill, you need a little bit less energy. And that's how we cut it back. We have valves that do it, continuous flow variable valves. And those are exclusive to us from a major defense contractor in the Northeast here.
Okay, yeah, very interesting. And so I find it great that you mentioned that it's specifically that modeling that you guys have done in the past that's your secret sauce. And so the other thing that you mentioned is obviously you guys can capture a large number of data through the machines and through the engines. And so with all this growing data, how are now the fleets operating differently, or what have you seen as kind of the biggest change for them? Is it fuel costs? Is it operational decision making? What's kind of been the biggest change?
Well, there are three things that at least I see in the trucking industry. And by the way, I'll continue talking about the trucking. However, this works for generators, which are obviously stationary. It works for construction equipment, which is obviously remote, where you need diesel engines anyway. But in the trucking industry, they're very cost conscious. So it's not only the cost per gallon, or at least here in the States, it's per gallon of diesel, but you're also concerned about locations. In the case of United Parcel Service, they route everyone to make almost exclusively right hand turns on a route, even if you're going a little bit longer, because they discovered that an idle engine waiting to make a left hand turn wastes X amount of time and X amount of fuel. So if you're controlling for the fuel and direct costs, and then you're controlling for the indirect costs of labor, those are the two biggest things in a very low margin business.
Mm,
Most trucking in this country are small mom and pop operations where they have less than 10 trucks. In some cases, it's only one or two trucks. And if it's idle, it's not making money. If it is stuck with higher fuel costs, it may be the difference between profitability and operating at a loss. So we try to answer the economic aspect. We also try to answer the environmental aspect.
right, for sure. So that's very interesting that you kind of answer both um, the ROI and kind of seeing how much they can save on using your technology and also make by using your technology, but then also the ideology. And what would you say from? And we're going to stick with trucking industry here for now, just specifically.
Okay.
But what would you say? How does it lean? Is it more? Do they care more about the ROI or the ideology? And what have you learned about the trucking decision making on investing in a new technology?
I would say most free enterprise people concern most about the direct costs. It's basically dollars to the bottom line. I mean,
Mm.
the fact that you can be more environmentally friendly qualifies you for perhaps government grants or for certain tax breaks, etc. And that's fine too. For some reason, I mean, not for some reason, for an obvious reason, diesel had a very bad reputation because of all the soot that's generated and all the waste product that does go up the smokestack. And we're simply using a concept where the more energy you get out of it, the less waste you're generating as a result of that. And we want to harness the energy anyway.
For sure, that makes sense. And so, do you guys partner with any environmentally friendly organizations or like other government boards? Have you guys gotten grants from those?
Well, not grants from government boards yet. However, I was just in Washington, D.C. last week helping a subcommittee on transportation in the House trying to establish parts per million standards for not only trucks, but also for any diesel engine. And in the hopes of having legislation that would incentivize people to pollute less. And if you're polluting less and getting better mileage out of it and actually using less diesel, we see it as a win-win.
Right, 100%. So there's an ROI and also there's an environmentally friendly benefit, which I think is really important in today's world. And so, kind of looking ahead, you mentioned a number of different industries that you're also operating in or looking to operate in, such as maritime and data center backup power. So, I'm curious, out of those, or maybe other ones, which ones do you think will adopt this first or faster, and why?
Well, I see standby diesel as probably working for the generator industry first. And when I say standby, live in an area that's very densely populated. There are a lot of housing that are multi-story buildings. There are a lot of seniors that live in some of these buildings, and they need to have a consistent source of electric supply because they're on medical devices. So the standby power in that particular situation is very high.
Mm.
Um, for example, there are public utilities such as sewage treatment plants and other places where you're controlling access to sensitive areas, such as power plants, etc. Power plants need backup.
Mm.
In the cases, where something falls down on the grid. So we can definitely provide that service, and we're an extra level of redundancy that can run those standby generators in those cases. Now, as far as maritime tends to use not only diesel fuel, but also heavier grades of fuel that have more sulfur and other compounds that are very bad pollutants. And a lot of the harbors are requiring either an improvement in the fuel, or they just won't let these tugboats and barges operate with that crude a level of fuel. So if we can be an answer to that, help remove high sulfur fuel from the equation, again, we're extending the life of the fleet that they have. So you don't have to purchase new equipment right away if you can extend your life. And again, we're helping Mother Nature out.
For sure. That definitely makes sense. Okay, very interesting. So there's definitely a move towards thinking about this and using this new innovative technology in all these industries. So that's definitely exciting. And the other thing is many climate conversations focus about replacing diesel entirely, but you focus more on improving existing engine performance. Do you see your technology as faster and more realistic path to reducing emissions globally?
Well, we are a transitional technology, admittedly, but for the next 30 to 50 years, I'm not worried about being obsolete.
Yeah.
There, it used to be an old Econ 101 concept that you have internalities and you have externalities in terms of costs. And one of the things that people don't realize, even in wind farms, none of the windmills that you see either in the mountains here in the Northeast or out in the ocean will ever pay back the initial energy cost it expended, and the carbon footprint that it took to build those. You basically needed concrete pads that required cement mixers. Cement mixers ran most likely on diesel fuel. The amount of concrete that goes in there would never replace the amount of carbon that was saved by the windmills themselves. And people think, well, we're going to be outside of a petroleum environment very shortly. The windmills themselves require grease in order to lubricate for performance.
Hmm.
So grease is a distillate, a petroleum distillate, pure and simple. And or at least that's what they use, unless we want to go back to beef tallow and use grease from animals. But
But
uh,
that's also,
that
yeah,
has its own problems. That has
yeah,
many of its own problems.
yeah. That's also very controversial to a lot of other people. So, uh,
Exactly.
yeah. So no, I totally understand, and I think that you're probably right. We can get away from using energy from the dinosaurs' bones and from the ground for at least, as you mentioned, the next 50 years. And so, interestingly enough, you mentioned that we're kind of like in this transitionary period, and that you guys are going to be the transitionary product and solution for carbon emissions. So I'm curious on this note, what do you think people of the new generation should focus on in terms of studying, learning, or developing their skill sets in? Would it be the hard skills like computer development to do all the data analytics for companies like yours, or would it be focusing on something more generalist? And in an environmental perspective, where should they also be taking an interest?
Well, unfortunately, I'm of the age where I was still a huge believer. First of all, I'm the son of an engineer and I'm the father of an engineer, but I'm the liberal arts guy crammed in the middle. And I definitely still see the value of a liberal arts degree, um, only because it gives us an ability to analyze and to think. No one technology is ever going to be the be all and end all. I mean, even computer programming now, if AI is going to be half as effective as it's cracked up to be, we're going to have the computers programming the computers. We don't necessarily need computer analysts, even though for the last 30 or 40 years, they made a very fine living and, brought us up to the AI era. I think that it's basically to learn how to be flexible and to be responsive. For example, EVs are wonderful things. Whenever I rent a vehicle, I like to have an EV because it's a lot of fun to drive, etc. But if
Mhm.
everyone converted over to EVs immediately, you would have a tremendous cost in carbon because you would have to reinforce every bridge, every road, and every parking deck because EVs are 50 to 60% heavier on the roads, and therefore there's more wear and tear on the roads. Again, that's an externality that most people don't factor into the cost, the true quote unquote cost of operating an EV. Is it basically a good thing for the air? Absolutely. But it's going to take a lot more infrastructure reconfiguration before everyone can afford to do it. And in the trucking industry, electric trucks are very good maybe in the short haul, but the weight of the batteries themselves cut down on the amount of items you can haul to deliver to customers. So again, that's another trade-off. Having a mind that can understand trade-offs and really decide what's important will be helpful. It's not that any one technology is the be all and end all. And I think, a multifaceted approach is the way we do it. Cybus just wants to be part of that entire configuration.
Yeah, I actually didn't know about the fact that vehicles were heavier. I knew that there was obviously a lot of emissions still used to create them, but that's interesting
Well,
to
and not only that, tires. You,
yeah.
you have no idea how much more expensive the tires are because they're lugging around 50% heavier, than what a internal combustion engine would do. So it's not a cheap proposition at all.
Yeah, yeah, and it's definitely not should not be happening as immediately, right, as we
Well, I mean, we definitely need an electric grid, and nuclear might be an answer for that. But people get very concerned when you start talking about nuclear energy.
yep. There's a balance. It's a balancing act between all of them, and kind of like what you were saying is trying to um, stay open and curious about different things that are coming out, and open to new ideas, and not just sticking to one specific solution as the answer. And so exactly what you said there, Peter. Very well put. And so tell us a little bit more about the next steps for Cybus and where people can find you.
Well, we're looking to basically get into different channels. Our issue is that since we are still a relatively young company, we're always capital constrained as far as what we can go into next. I mean, if I had, if I won a couple hundred million in the lottery and decided to put it into Cybus, I would probably have 5 or 6 different channels, to handle the maritime, the trucking, the generators, the construction equipment, etc., the mining equipment, pumps, um, backup generation for data centers. All of those are separate channels. They all run on a similar concept, but each marketplace has different constraints and different values. So that's what I would necessarily do. I mean, we still see that there's a possibility not only for long distance maritime, but perhaps even in aviation, there's a need for our services. But again, that's 5, 10 years from now. We're more concentrating on generators and trucks today.
Okay, very interesting. And so we can tell us more about the website we can find you at, and where people can find you, Peter Stark, as well.
Okay, it's www.cibus21.com. That's CIBUS, and then the number 2 and the number 1. One string, no spaces.
Amazing. Yeah. Thank you so much for this conversation, Peter. I really enjoyed it. I think we touched on a lot of different subject matters from environmental hazards and also climate change, as well as how to move forward with that, as well as using technology. So I really do appreciate it. And thank you for your time, Peter.
Well, thank you very much. It was an honor being here, and I look forward to talking to you again, maybe in a year's time, to tell you our new progress.
Yes, that will be super exciting. Thank you so much.
Thank you.